Once again, warm welcome to all the viewers of this particular webinar, and warm welcome to all my panelists. So as Nidhi mentioned to you, today's discussion is around building digital infrastructure to ensure supply of vaccines and timely vaccination. Today, we have along with us the speaker, Professor Dr. Saundar Kumara. He's actually a professor of industrial engineering from the Penn State University's Park campus and an esteemed scientist with research focus on sensor-based process monitoring, chaos theory, digital threats in manufacturing, AI and ML in manufacturing, healthcare analytics, and graph analytics. So I would like to introduce him with his photograph so that you'll be able to see him live and hear from him what he has for us. He's actually worked extensively on military and industrial supply chain logistics, infrastructure problems. He is also armed with Fellow of Institute of Industrial and Systems Engineering, International Academy of Production Engineering. He is also a member of American Society of Mechanical Engineers and American Society of Advanced of Sciences. So take us through for the next 10 minutes. I would request Professor Saundar Kumara to address us. Over to you, Professor.
Yeah, thank you very much, Ratnakar. Okay. When Dr. Damodar Acharya sent me an email and asking me to talk in this conference, my initial reaction was, I don't do anything with vaccine, so I may not be the right person. But I'm very encouraged from the last panel, especially when Masanari arrived and talked about real-time monitoring, and also Dr. Mahesh, he also talked about having the visibility of the supply chain end to end. And I've been working in sensing and trying to figure out the situation awareness for a long time in my career. And therefore, I feel what I'm proposing is right segues into the previous panel's discussion. So what are the key takeaways I would like after this 10 minutes from my conversation is the smart vaccination supply chain is a technology which is cross-cutting and research, technology, and development for IT, information technology, and OT, the operations technology. That is one takeaway. The second takeaway requires this is SVSC requires the development of operating system for cyber physical vaccination ecosystem. These are the two takeaways from my talk. So about this, a lot of people talked about even network. Essentially here, I'm trying to show this slide that to state that India has the infrastructure in terms of distributing the vaccines. And then how far it can go is a question which everybody has been asking today. So all this are known points, therefore I'm not spending time. So everybody talked about platform. So what is a platform? Platform, the way it is defined by McKinsey, is a business model that creates value by bringing together consumers and producers. So there are three kinds of platforms. One is the transitional, where you have the individuals and organizations are interacting, like Uber or Airbnb, eBay, Amazon, etc. So they kind of work in a marketplace. Then you have what you call the innovation platform, where you have a hardware that is defined, and you have an operating system that is defined. And if it is open, it's much better. And then you can hang on any application. Therefore, this leads to tremendous amount of innovation. You are crowdsourcing innovation to people. So this is the second kind of platform. The third kind of platform is an integrated platform, wherein we have both the transactional as well as innovation together. These are like the Microsoft Azure or the Amazon Web Services, etc. So here you are looking at the users and the producers coming together, and you have technologies like AI or cloud computing, and then your sensing and also your data. All these things in terms of the operations and also IT. So this is the structure I envisage for the smart vaccination supply chain platform of the future for India or in the global context. This is everybody knows about how COVID, the vaccine comes from a factory to the end point. Here, the doctor is shown as the person who is delivering the end product to the patient, vaccinating the patient or the individual. And people talked about the cold chain and then how you can, how what they need to track everything. All these things were mentioned uh, fairly well right from the morning till now. So if you're going to create or if you're going to work with this kind of a supply chain, we need a reference architecture. So for a platform, you would definitely need a reference architecture. This reference architecture here, we look at collaboration as one vertical, business models as another vertical, and operations as another vertical. And then each one of them, I go through in a little bit more detail. They're held together, these four pillars of the reference architecture. So in the collaboration, you have the different players, right from healthcare professionals or the frontline workers, NGOs, or the old people homes, or the 3PL and then 4PL logistic big providers, the manufacturers, physical cold chain equipment, and also the regulatory bodies. All these are the players who are going to be at the almost the physical level. They form these networks, and then you have the data that models that are being built on this data that is generated, and the processes that happen at the physical system level, or the distribution, storage, or the time series services which you have to give, when and where things were, and then the cloud and edge computation, and then pilferage or counterfeiting detection services. All these are necessary at the collaboration level. At the business model levels, we are looking into how do we optimize the system. Therefore, transit analysis becomes an important point. Storage becomes another important consideration. IoT, cloud, and edge, another one. And here the analysis is a little bit quasi-real time. We really may not need the real-time analysis. Whereas if you take at the operations level, that is where the sensors and the devices, if you are looking at the bottom level. And the last mile delivery, this is where we are going to be looking at all the sensing and the data loggers that come out of it. And the sensing data is stored onto the either IoT, whether to do it on the edge or whether to do it on the cloud. All these questions are going to come in. And therefore here, control needs to be exercised, how well you're going to use it in the last mile. And then here again, you need to worry about in real time pilferage or counterfeit detection. So the most important point here is in terms of the real-time analysis. So the four pillars of this reference architecture are, one is the interoperability and then standards and the protocols. And the other one is security and the cyber security, safety and resiliency. The third pillar is going to be human systems interface, because people are going to be interacting with these systems or with this platform, and data services. So if you put all these things together, we need to design the system. We need to measure how the system is going to be working. We need to predict in terms of when you are actually picking up real-time signals from the sensors, and then you want to do the control. So the founding technologies, if you go to what we need a platform communication language and operating system for this smart vaccination supply chain reference architecture. You need communication. Locally, you could do edge, maybe a local network. And then globally or at a higher level, you are looking at mobile or cloud computing. And then for analytics, we will be using AI and machine learning. Both they can be at the edge or they can be at the cloud. For example, when I take machine level data, I can do it on the edge. Raspberry Pi maybe it does to some level, but if I go to Jetson Nano, I can do it much faster and much more efficiently. So then the question here in real time when you are dealing with the vaccine supply chain is what analytics, and then when you are going, how you're going to use it and where you're going to use it. And tracking at every level. We need a data structure for tracking at the vaccine level, and perhaps that needs to be enabled by a blockchain. So the inferencing from the data that you are collecting, that is going to be AI based. So what services are needed to do this, and what data is needed for a particular inference you want to make. What I mean by this is, did I really conform to the temperature specification? Suppose you ask that question, then I should be able to come up with that inference. Then my system should be able to know what data would be needed and what kind of a service should I call, whether at the edge or at the cloud. So the major challenge, like Masanari-san was talking about, real-time monitoring and control. I spent 30 years in that particular field, dealing with manufacturing. And then the real-time distributed management, though you have the central operational control, the vaccine distribution is going to be in a distributed manner. Whether here, again, to edge or not to edge is the important question. Integration between Aadhaar, even, and the vaccination health record or EMR. Maybe we need a vaccination health record. So why is that important in the digital platform? At the transaction level, if you look at, I built this diagram specifically for our purposes. I used McKinsey's IoT stack configuration. You have the platform layer, all the business applications, development environment, analytics services, what you need, visualization, e-commerce, or security services, regulatory services and data wrangling service, and device management. If you look at, we need three things at the last mile when you actually are dealing with the individual. Pre-vaccination, what do we have to do? What data we need to collect? Right from provisioning for this data to authenticating the person, to geo-mapping to visualize where the person is and what is being done, where are the collection of people. And then while you're vaccinating, we need to worry about cross-contamination. Somebody who already has COVID maybe is standing in the line, who knows? So even if you prevent it, even before, one does not know. So we need to worry about all this. And then post-vaccination is very important because we do not know the efficacy of all these vaccines over a longer longitudinal time period. So if you really want to follow this, obviously we need to have an efficient tracking system and also an efficient data collection and storage that is a part of this platform, which I propose need to be open source. So in terms of analytics, what kind of analytics we are talking about? This is some work we did on the COVID data. This paper came about in about, I think, September or August. Myself, my colleague, and my students, we looked into the county level data in the US, 3,200 counties roughly. And then we used comorbidities as well as the age and both the demographic and some clinical parameters in terms of comorbidities, and try to figure out the vulnerability of each county. So perhaps the vulnerability here, both from the point of view of what do you call, there was a reference to two things here, the frontline workers who need to be vaccinated. The second one is the vulnerable population. In order to enforce equity in distribution, some kind of a model like this. Here we use like gradient boosting method in from machine learning and some AI inferencing to develop this whole county map. This is even before the data was freely available. So public-private partnership, obviously, the even Aadhaar and the voting systems. I don't know too much about the voting part of it. Voting is a little bit one-sided. People go vote. We don't track them afterwards. Therefore, tracking here is going to be much more complicated. Though having said that, but still, it might be a good idea to use our learning from that in order to build. All these things are in the public sector, and you have a lot of companies coming up with blockchain platforms for tracking food or tracking vaccine and also tracking counterfeit drugs. So this is the other point. So the blockchains for information visibility, and then also blockchains for tracking as well as analytics to be able to identify anomalies to figure out what is happening in the system. So these are the few points I wanted to make. And finally, to as a concluding statement, we need a reference architecture. If you are going to, we need a platform. Platform need to be like open source. And if we want to build a platform, we need to have a reference architecture. A reference architecture gives the stacks and what needs to be done and what kind of a data that needs to be collected and how, and all these services that are going to be put on top of each one of these layers in the platform are going to be almost open source. Anybody can build a service like apps people are building for iPhone or Android. So that is, I believe, could be a bright future in terms of building a platform for. Then I had to give a name because it is going to combine all that is existing as a smart vaccination supply chain platform. Thank you very much for giving me this opportunity. And the last 2 months, I learned a whole lot about vaccines and vaccine supply chains because of this call for today. Thank you.
Thank you, Professor Saundar. It is wonderful listening to you. We appreciate you staying back a little late and then enlightening us about various aspects. What was very, very interesting is you mentioned about a couple of areas, which is your last mile, the point you mentioned about lab to doctor's office. I think it's a fantastic in a problem area where everyone is looking at how do we solve that. You also touched upon the smart vaccination architecture in terms of what services to be used, what data to be needed, what are the challenges in terms of real-time monitoring, geo mapping, coverage visualization. So I'm sure all these things are actually points to ponder for in the next 30 minutes in our panel discussion. Thank you so much for setting the stage for us to have a deliberation on these specific areas and maybe understand a little more from our esteemed panelists. Today, in our panel discussion, we are very, very fortunate to have two important, very, very esteemed professors with high academic credentials with us as a part of the panel. And we also have two important individuals who actually are steering the startups in this particular space. So we have a very, very good mix of professionals helping us to navigate through in the next 30 minutes, answering to us how digital can address some of the areas what Professor Soundara has actually enlightened us. So before I go further, I would like to introduce our panelists and give you a quick glimpse in terms of their credentials. Of course, we all the professionals, all the panelists here are of esteemed have esteemed credentials. So I need not spend much time, but it's important for us to understand the kind of legacy they carry with. So Professor Viswanathan is actually INSA senior scientist in the computer science and automation at the Indian Institute of Science. He's a professor and executive director for the Center of Excellence, Global Logistics and Manufacturing. He was also a faculty member for the Indian Institute of Science for almost close to about 25 years. He was the chairman, Department of Computer Science and Automation from 1990 to 1996, and he is a recipient of 1996 IASC Alumni Award, and a number of such awards are bestowed onto him. He is a fellow of IEEE, a fellow of Indian National Science Academy, Indian Academy of Sciences, Indian National Academy, and the World Academy of Sciences. So, Professor Viswanathan, warm welcome to the panel, and we are fortunate to have you and would like to listen to you. Before we come to you for your questions, I would like to introduce my rest of the other panelists. We heard about Professor Saundra, again an esteemed professor from United States. Once again, thank you so much on behalf of all the panelists and the participants, Professor, for staying back late in your night and again enlightening us. We would like to spend more time with you in the next half an hour. Ajit Kumar is actually the CEO and the founder of RealMeds. It's a modern track and trace and anti-counterfeit solution. I'm sure all of us actually are trying to address this particular menace. And today, Ajit would actually like to give us in terms of what are the emerging techniques or technologies addressing these challenges. He's a serial entrepreneur, and RealMeds is his third venture. He is an expert in building scalable business models based on niche technologies from ideation to execution. He has over 2 decades of experience in employing these technologies to solving the problems. He is an open source evangelist and is also author for a number of such areas. Last but not the least, let me take the privilege of introducing Ajit Pai. Ajit Pai is the COO of Delivery. He is responsible for ensuring the smooth delivery of the products and services, especially from the supply chain perspective. We all understand and appreciate that. He manages the efficient functioning of Delivery's network, ground operations engineering. He is the CFO of Delivery and is also handled multiple roles in the Lodha Group. So without taking much time, I would like to now point this question over to Ajit Pai. Ajit, can you please enlighten us in terms of, you heard about number of nuances as far as the supply chain is concerned. Can you address us a couple of the areas which are actually very, very important, relevant as far as the digital technologies are concerned, and what kind of nuances do you see in the vaccine supply chain?
Sure. Thanks for the opportunity. It's been very enlightening to hear the views of the panelists so far. And Professor Soundarajan actually just laid out a whole bunch of things that are very, very critical as a theoretical framework and as a practical sort of next step to how this can be implemented. I think there are two key nuances to the vaccine supply chain. And one part of it is completely on the physical infrastructure side, which is with regard to basically the availability of refrigerated equipment, so to say. Now, whether that is fixed equipment or it is movable equipment, both of those are equally critical, right? But the topic of this discussion is more about. So I think there is a need to understand what the gaps are on the physical infrastructure side, right? But equally, okay, the physical infrastructure without the digital tracking of it will not give us the results that we need, right? What I think Professor laid out, I think is the most important thing, which is if you boil down everything to what is required, what we need is basically leg level traceability of every single transaction that happens in the supply chain, right? Why is this very important? While it is sort of while it is a fairly easy concept to understand, to actually practice it, right, is where all of the difficulties lie, so to say, right? And more so especially in India, where historically the supply chain has been very, very fragmented for any sector, right? Delivery itself started out 10 years back with exactly this problem, saying that digitally one has to understand what is happening in the supply chain. There's a very famous saying by Fred Smith, the CEO and founder of Federal Express, which is that the information on the parcel is more important than the parcel itself, right? Frequently, I think that comes to the root of what the nuances in the vaccine supply chain are, which is that every dosage of vaccine has to be tracked along with possibly about 40-50 different sets of information about that dosage, all the way from the time of its manufacturing to the admission to its movement to the last mile and across a vast landscape, right? And then what I would call as, let's say, for example, in a consumer durable world, what is called as a post sale service, right? Where effectively you not only need to track what you've delivered, but you also need to track what's happened to it after you have delivered it, which becomes critical information. Now, what are all the nuances that come in? I think some nuances are very India specific, like for example, the fact that addresses in India are not easily understandable, right? Are not in a very structured format. I think those are nuances that are important for any supply chain. They become important in the vaccine supply chain as well. And then there are the whole set of nuances which lie around uh, the digital traceability, right? The answer, I think, lies in the platform approach. I think that's been fairly clearly laid out by Professor, and I think in practice it is true that the platform approach is the only one which will resolve it, because no one agency or company or provider will actually be able to have the end-to-end infrastructure on this digitally or physically, right? So having a platform which is open source, where anybody can rig into in some sense, right? uh, and the platform defines what has to be tracked and how it is to be tracked. I think that is the real nuance of this, and that will lie across multiple points. So you have the warehousing side, you have the cargo side, which is bulk movement, then you have the bulk break, and then you have the last mile, right? I think that's where all of this lies. So I think from a nuance perspective, we are talking exactly about the problem that Professor has laid out.
Thanks, Sachin. I think you've very nicely alluded in terms of challenges from an infrastructure, both physical as well as digital. So, with the kind of problems what you have actually now alluded in terms of these challenges, I would now turn towards Professor Viswanathan to help us understand from his perspective what kind of infrastructure availability is there, a supply chain perspective. How can we actually circumvent these challenges? What Professor Soundar has actually alluded a couple of minutes back, and what you just actually also spoken about the challenges from an infrastructure standpoint of view. Professor Viswanathan, can you please help us understand more from your perspectives? You are on mute, Professor.
Now, can you hear me?
Yeah, you're audible.
Okay. So, yeah, I'm sort of working on this COVID-19 effect on supply chains, as well as their effect and how to design ecosystems and platforms. So as far as our discussion is concerned today, there are two kinds of infrastructures. One is hard infrastructure, which everybody is talking about. And the second one is the soft infrastructure, which is the software platforms and so on, which Sundar has talked about. And what are the important things for a supply chain like the vaccine? First one is the traceability. You want to know where it came from and how it has traveled all over, and whether anybody has contaminated it and so on. So that traceability becomes an important issue. So, and then there are a lot of innovations that are coming up as far as supply chain and things are concerned. Like, for example, people collect the big data. From the data, is it possible to say when somebody comes for vaccination, he has already had a COVID? Is it possible to say whether he had high blood pressure, high this one from this one? So if you have digital records of these people who are coming for this one, I think it is an opportunity for India to create digital records in the name of COVID, digital medical records. And once you have this data, then you can use the platforms like AI and ML algorithms, the machine learning algorithms to do this. Now, the point here is that it should be an open innovation. In other words, just because the governments are involved, it cannot be done by the governments and the cold chain logistics people and so on. Then the vaccination centers, where are the vaccination centers? Is it in high schools? And people are talking about like, we are doing like the voting, like central voting systems, which are held in high schools, which are held in various places. So what are the kinds of facilities that are needed, the doctors, the cold storage, and so on? Is it possible to have vaccine trucks where they can go to the villages and the vaccine truck can have some refrigerators? And it all depends on what is the kind of vaccine you're using, what are the temperatures and so on and all that. So it's basically taking into account that we are in India and most of the people stay, 90%, 80%, 60% of the people stay in the villages. And if you want to do the village vaccinations, etc., then you have to, how do you convert both hard and soft infrastructure into the villages and so on. So, and another thing is, what in terms of public-private partnership, you should have all the hospitals, the startups, and all the logistics, 3PLs, 4PLs, all the logistics companies into this one and form a sort of an ecosystem. And the ecosystem can be a platform and so on. So what becomes important here is governance. In other words, if you are talking in terms of management literature, it is what is called governance. How do you govern? Tell people what to do, what they are doing, when they should do, when they should come, and so on. So that governance comes in from what is called it is called in the logistic literature control tower. In other words, is there some control tower which collects all the information about the patients, about the vaccination centers, about the vaccines, where they are going and so on, how many people have vaccinated, what is the data they have, and all this, if it is controlled, then you can have you can develop from those things. And also these vaccination centers can be designed using what is called the scenario planning. No, we don't have like vaccines there. Everybody is talking only about vaccines, how they are prepared and how they are delivered and so on. But when you are talking of 1.4 billion people and 680,000 villages, and where these things are to be done, nobody has planned, and scenario planning, and as well as the simulations and the governance mechanisms need to be developed. And the control tower concept will help on top of what Sounder has presented in terms of the platform to do this and so on. So, but there are a lot of startups which are working on, I advise a lot of startups which are working on the supply chain logistics and so on, and they're using all kinds of technologies, APIs, application programming interfaces, which basically help to connect various people, various parties who are involved and so on. So I think the digital infrastructure to be developed for this COVID vaccination is a very important question. Yeah. And developing this, it can be useful for other purposes also, for your health, for your voting, for your Aadhaar, for your and so on and all that. So basically, one thing that should not happen is people's COVID should not be transmitted when you go for vaccination, right? So yes. How can you ensure that the people who are going there, you team up, and then it should not be transmission. So if you take the digital or any other this one, what are the so-called performance measures that you say? How many people are vaccinated? How many people are immune? how many people are transmitted.
Sure.
So
Thank you so
people,
much, Professor. I think it was wonderful. You brought in the two important elements. One is open innovation, and second is scenario planning. I think they're actually very, very important and significant from the current standpoint of view. So to further understand in terms of what can India learn from the developed markets, I think we could see some amount of traction already built in the Western world. Professor Sounder, we will request him to actually enlighten us in terms of what India can actually look towards some of these learnings from the developed markets. And Professor Sounder, so look forward to your views, please.
Like Mr. Pai talked about a little bit before, in the sense of the theoretical notion of the reference architecture and the practicality of implementing some of these things in the last mile or even in the whole system. These two are very, very important components. The reason why I even talked about this reference architecture is from my experience working with the DARPA on military logistics, number one. Number two, recently, last 2 years, I've been working with Clean Energy Smart Manufacturing Institute, which is DOE's effort to revolutionize manufacturing in the US. One of the calls there is how do we take the legacy systems which are there and then make them fit into this so-called digital smart framework. So this is one of the practical examples I can talk about and deal with, or the two examples I can talk about, are things I worked with some of these industries. So I think in order for us to go into the future, 10 years from now, look back and say, what did these vaccines do to the people? And then what was their efficacy? In order to do that, even though it is very difficult, I fully understand how can you go to a remote village and then from there you collect the sensor data, etc. But whatever you can collect, at least to the level you can. Suppose we come up with a vision of proposing this as a mechanism into the future, and then combine it with the practicality of actually making these things happen from people like the delivery company or with Ajit Kumar here, then I think we are into this for a long haul. And then the problems which are not solved today perhaps would be solved. Because the work, that is what I would say we can pick up from the, if you want to call American experience. There are a lot of things which are done maybe 20 years from now, things will happen. That's how some of the DARPA projects are. And when you're doing it, you know that there's no way this is going to happen. But then you realize when you look back 20 years back, oh, we worked on this, that has become a part of this particular system. That is my, what do you call, 2 cents. And also I fully understand how are you going to track an individual when the individual's address is not there? Or in the same address, 10 people are living. So I worked with the other group long time back before they actually started doing things. And I was called to look at how do you eliminate fraud. Then I was looking at individuals and their locations and then addresses. I could not disambiguate them because two people had the same name living in the same address. Who am I tracking? So, but however, the tools and then the reference architecture or the models developed or we are proposing or this panel is looking at perhaps will become reality 10 years from now. So that is the experience from the Western.
Yeah, thank you so much.
Thank you.
You did actually mention in your talk also about the geo mapping and coverage visualization. So I think some of these elements can try and address some of the areas what we are today grappling with in terms of challenges. So we will turn towards Ajit Kumar. Ajit himself was leading number of startups in this particular space. And Ajit, can you actually help us understand what kind of problems were faced earlier from a technology perspective in terms of these such kind of mass programs? And how do you foresee the situation now? And how can this be actually be learned from the lessons? We just heard from Professor Sounder about some of the learnings from the Western world. And can you enlighten us from an Indian context?
You are muted, Ajit.
You are on mute. Yeah.
So am I audible now?
Yes.
Yes.
Okay. So first of all, thank you so much, everyone in this panel and the audience for this opportunity. And Professor Sundar for putting together that nice architecture. I can totally relate to that because that's what I've been trying to put in practice as part of RealMeds day in, day out. So coming back to the question, Mr. Ratnakar. So in my experience, when we have a problem at this scale, there are certain things which become very important. And one thing is compliance and standard is something that I would really like to highlight, which was again the first pillar of Mr. Sundar's architecture. So why it is important is because now the vaccines would be coming from various manufacturers, right? And they would be crossing borders, right? It would not be like Indian vaccines will only be distributed within India, or they would be going everywhere. So having a compliance in sense that it can actually comply with the global supply chain, right? And following some protocols or standards like GS1 would be very critical, so that whoever is doing serialization for these kind of medicines, as long as they comply with that, those medicines can actually flow effortlessly or with no friction within the global supply chain, and they can be distributed and tracked very easily. So that's one thing which is very important for a problem of this scale. Second is, we all know that whenever there is a big problem, there is a big opportunity for the fake market as well, right? That's how the fake market sees that as an opportunity. So then this very next thing which becomes important is how do we protect each of these brands and also the consumers or patients from this counterfeit or the fake products. So having a very elaborate system in place which can actually do multi-point checks in order to protect. So whenever a caregiver is giving a vaccine, if they can quickly make sure that they run through the counterfeit check to figure out whether this is okay to give or not, right? So if they get a very quick answer in terms of yes or no, that would be very useful in this scenario. The next would be is the monitoring. I think in the previous session, and I think that's a common point, is that for vaccines is the overall temperature and the condition monitoring of the vaccine. So I think it is a two, I would say, the problem is like two facet. So on one side, the cold storage is saying that, okay, we can do this, we can do this. However, in spite of all that promises, we still have manufacturers who have no clue. This is based on my practical experience. They have no clue whether their vaccine is really kept under that temperature from the source till the destination, right? So certainly, so we basically, for example, we provide a mechanism for manufacturers to actually understand this, where we provide them a device that they can actually put it inside their package. Now, how that package is going, whether through road or by air or by ship, doesn't matter. They get the complete visibility data about what had happened to the package actually. And that enables them to actually sit across the table and have a better conversation with all their logistic providers to ensure that why this is happening or how we can actually put this in place. So I think while we take care of the one part of the problem where storage companies are saying that they are doing it, but I think at the same time, we also need to enable the manufacturers to make sure that they trust that statement, and they also have a visibility into that, because at the end of the day, if something goes wrong, they are legally liable to explain why this medicine gave any kind of reaction, right? So they are responsible. So they need to have the data visibility so that they can respond to those legal notices in a better way. And finally is the ease of onboarding the different participants, right? so that there is a common platform or there is a common data exchange mechanism in place where everybody is looking at one data at any given point of time. So it is not like the data is flowing from one system to another, rather than it's like everybody having a common view to the same data, so that it's real time, it's accurate, and everybody has the same understanding of the data basically. And finally, one thing that I would like to add is, in these kind of programs, it is also, in my personal opinion, it might help to have an incentive model built into the digital platform. So that way we can encourage people or the participants of this whole program, we can incentivize them differently, right? So that they're encouraged to either participate in this program, get their vaccination done on schedule, right? Get the repeat vaccination done on schedule. So having an incentive program would also enable us to actually run a program of this scale. So those are the key points that, in my experience, for a program like this would be really useful from a digital platform perspective.
So very thought-provoking point you brought in, Ajit, in incentivizing the population to ensure that they are actually being vaccinated and they comply to it. Thank you so much. It's wonderful to have the perspectives from all the four panelists, very esteemed panelists, and I think we got lots of information in terms of what could be the digital interventions. So I have a couple of questions from the participants. I thought we can actually spend a minute each in terms of addressing each of these questions. Professor Viswanathan was actually talking about role of public-private partnership, and the question is around where do you think and what do you think is the role of public-private partnership? Professor Viswanathan, can you please highlight us what, according to you, is the need today in terms of this public-private partnership?
I mean, there are a lot of private things. I mean, public partnership with the government and so on. But from vaccine makers to hospitals to startups to IT companies to various logistics providers, they are all private people. So, but what happens is, there is certainly, while people talk about how to design a vaccine, people are not talking about how do I deliver it from here, what are the steps that are involved, what is the scenario planning, if a thunderstorm comes, what will happen, if the truck fails, what will happen, and so on. So basically, there is a tremendous need for open innovation and data sharing, and having a big data platform, and sharing all this data in a collaborative way. That's what I mean.
Thank you, sir.
And also there is another point where startups, there are platforms which are needed. There are platform at the vaccination center, because vaccination center also has all the players that Sounder has this one. Also at the government level, there are several platforms. So it is a hierarchical model where you have a big platform and a small platform. And all this government public people cannot do. It has to be done with cooperation with the partnership of the private companies. And also there is, as everybody has pointed out, from vaccines to data, everybody steals. So how do you secure the data? How do you secure the vaccine? These are all the issues. So, and I would also suggest to the government that they are supporting a lot of vaccine developments, but they are not supporting, I mean, today or tomorrow or day after, the vaccine has to be delivered, and all the people in in entire India has to be vaccinated. So how do you do it? What is the logistics? Do they have any research projects on this? No. No funding on the research projects. So it has to be done.
So thank you so much, Professor Viswanathan. And turning towards Ajit, the question to you is, digital interventions, number of digital interventions are tried. And can you highlight one or two things, what did work and what didn't work? Ajit,
Yeah. Sorry, I was on mute. So I think a couple of things that has worked for us in our journey, right? And I'll make this a little more generic because, it's not like we have distributed vaccines or anybody else has distributed vaccines at the last mile to this at the same level that is being spoken about now, right? A couple of things that have worked for us, and one of those issues, for example, is what Professor raised also, which is about the addresses itself, who stays where, etc. Right? Like in our case, for example, we have been able to build a system where today, if we have delivered to any address or any person, and when I say a person, it is defined by a location, right? Once, right, we are actually able to create through our own data, we are able to create a unique ID, okay, by disambiguating the address of that person. So effectively, let's say the person stays next to the Shiva temple, which exists on the main road of some village. I think the what I would call as the middle mile of it is very easy, which is that you have to get to that village, right? And then there is the last mile, and then there is the location itself, right? Because India does not have roads, road names, blocks, sectors in whatever 95% of the case. We've actually been able to use a combination of geolocation, the person's phone number, the disambiguation of that address, and training our systems to actually read that address, right? Which basically means that if there are 10 different words in that address, our systems can read those addresses and piece together with a 95% probability who the person is and where does he live, right? That's worked well for us on the e-commerce side, for example, because we are now in our history of about 9 years now, we've delivered close to about 750 million parcels across the country to possibly about 100 million unique people across the country. And when I say people, it could also be multiple people living in the same address, right? So the data systems that we have built we've been able to actually understand how to deliver. So, for example, today when a new parcel comes into our network for the same person, our systems, even if, let's say, for example, the address is written slightly differently, where, for example, instead of writing near Shiva temple, somebody writes it as near temple, and after that the locality name, and the locality name is spelled wrongly, right? Our systems, using probabilities, are able to actually zero in and say that, look, this is the same person we delivered to 1 year back on this date, and hence, if the delivery boy says that this address is wrong, please go back and tell the delivery boy that you delivered to this address earlier, right? I think those kind of systems that have worked for us over the last 7-8 years, and I'm not sort of saying that that's the only thing, but these are the kind of things which will have to come into play here, right? So I think to that question, I think this is one example of what is important, and there are certainly many more that are important.
Thank you, Ajit. We have, again, number of questions lined up. Unfortunately, we have limited time. So thank you once again. I think it's a wonderful observations and deliberations by each one of you. Some of the key points which Professor Sounder has actually brought out in terms of collaborative ecosystem with smart vaccination architecture, which he brought in. And similarly, what Professor Viswanathan was talking about areas like open innovation, and Ajit Pai and Ajit Kumar talking about the various needs of these technologies all put together, embedded to create a system wherein we have a seamless distribution for what we foresee as an integrated view for our vaccine supply chain. Thank you so much for all of you for your time and enlightening us with all your perspectives. And thank you once again for your time, Professor Sounder. Once again, on behalf of everyone, thanks a lot to you. I'm sure we are holding you late in the night. Thank you so much for your time.
Yeah, no problem. Dr. Ratnakar, thank you. And Ajit Pai, Ajit Kumar, Dr. Viswanathan, thank you so much.
Thank you, sir.
Nice to work with you again, Dr. Viswanathan.
Thank you.
Thank you, Dr. Ratnakar.
Thank you so much.
Thank you.